This is assignment number 4. In this assignment, you're going to be looking at the communication link. And one of the first things that you need to do when you create a communication link is to convert the message into a binary format. So to do this, you need to change the message into binary zeros and ones and create a data stream of zeros and ones. One way of doing that is to generate a random set of code words that can be used to translate the message into a coded message. So the first thing that you're going to do is create a script. Recall that to do that, you go up to File, New, Script, and this is going to be called aircode.m. Again, do not use semicolons at the end of the commands in your script file so that you can see the message on the screen. So I'm going to suggest having both these windows open, the Matlab window and the editor. This is an overview of the air code. Once it is run, you can go back and check to make sure you have it all completed. The first thing you should have is the zeros and ones, 4 zeros, 4 ones. The next is this Perm_8 matrix. It's a 4 by 8 matrix. Each row should contain the numbers 1 through 8 in random order. The next is this rand_code words, and you should be able to check to make sure it is correct. At each of the same locations as that of the Perm_8, you should use the value in the Perm_8 to look up the value of the 0, 1 in the zeros and ones array. As you can see here, it does look correct. Next, you should be able to have the number of code words, which should be the number of rows, 4. The length of code words should be 8. And those are both correct. Next, you should have the binary data. In this case, it's a 0, 1. And the transmit word should correspond to the 0, 1, which is 1, the same row. And in this case, it is correct. To check the center code, you might want to retype at the end center_code along with the rand_code words to check to make sure that it is extracting the correct location of that. So again, it was the rand_code words and not the rand_matrix. So checking this, I do see that this is extracting the second and third rows with the 3rd through 6th columns. And it is correct. Now we want to have the creation of the rand_matrix. It should be an 8 by 8 array or matrix, 8 by 8 matrix, and it is, and it's varied numbers. Now new _code words should be the absolute values in the rand_matrix, and if the absolute value is greater than 0.5, it should be a 1, otherwise it should be a 0. So you can check, and it does look correct. The new _code words 2 is the flipped column, so the column on the left should be on the right, and the right should be on the left. The single _code word is the diagonal, so you can check that to make sure that the diagonal is correct. And the inverted _code words should be the inversion of the new code words too. So if you need to type out that one to compare them again, you can type it back out to have inverted _code words.
and be able to compare that with the new code words too. And the ones should go to a 0 and a 0 should go to the ones. And that does look correct too. So diary off, and that's the completion.
So the first thing that you want to do is create a zeros and ones function. This zeros and ones array should look like this. It should have 4 zeros and 4 ones. To do that, you're going to use a function called zeros and a function called one. Again, to see how the syntax of this works, you can do a Shift F1 at the prompt, and you'll see the help window come up, and you can do a search here for zeros. And you'll see that pop up for the function zeros, and then if you move the cursor on top of it, you see that it creates an array of all zeros. So if you do zeros n, it returns an n by n matrix of zeros. If you define m is always going to be the rows and then the columns. So this would be an m by n, m being the rows and n being the columns. So if I click back on the main command window and I do zeros 4, you should expect to see a matrix of all zeros with 4 rows and 4 columns. If I define 2 rows and 5 columns, that would look like this. The first number is always how many rows, and the second number is how many columns. So again, we want it to look like this, where we have 4 zeros in a 1 row and 4 ones also in the same row. Take a second to pause this video and create the first part of this, which would be a zeros, which is 4 zeros in 1 row. The result of that would be that you would need to put 1, 4, and this will create a row of 1. That's what the 1 is first, with 4 columns. The syntax for ones is similar. Again, you can do Shift F1 to bring up the help window where you can search, and you can type ones. Again, you'll see the ones pop up, and again it's the same thing. Ones n returns an n by n matrix of all ones, or you can define it as m by n, m being how many rows, n being how many columns. You also want to put on the back of this, which would be all ones, so we want to also create the same thing, which would be ones 1, 4. So now you have the 2 arrays. I want you to take a moment to try to think about how to create them together. So pause this video, think about how to create the ones and zeros array. Look like this. The next step in creating the coded message is to create this Perm _8 matrix. What you want is you want 4 rows, 1, 2, 3, 4 rows, and on each row you want it to have 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. And on each of these rows you want it to be from 1 to 8. As you can see, it uses 1, 2, 3, 4, 5, 6, 7, 8, and they're in random order for each row. There is a function called rand_perm that can be used to do this. So again, Shift F1, and you can look up the syntax of this function. So here's what it is. Rand_perm, if you put just one number in there, it returns a row vector containing a random permutation of the integers from 1 to n inclusively. So you'll create for rand_perm, if you put in 9 here, it would create one row vector with all 1 through 9 in random order. So if I do rand_perm 10, I see that I have one row with 10 numbers 1 through 10 in random order. If I do that again, you'll see that again I get another different random ordered from 1 to 10, and you can continuously do this, and each time you'll see that it does vary each time. So again, what we want to do is create this Perm 8 matrix, 4 rows. Each row contains a permutation of the 1 through 8 using rand perm. So I want you to pause this video and think about how you're going to create this array and try to implement it yourself before seeing the answer. So here's a first attempt at creating this Perm_8 matrix. Again, I want 4 rows with 8 columns across. So I've created a vector which will have 8 random numbers, and then I've created another one, and then a third one, and a fourth one. What you'll see when I return is that these do not go to a new row. So you got to make sure that when you do this, you will separate these out into a new row by using a semicolon. If you use a comma, you'll find that that also just creates one row vector. So here you see the creation of the Perm_8 matrix. 4 rows, 8 columns across, and if I do it again, I'll see that I get a different matrix as far as the values within the matrix. The next step is to create an array called rand_codewords. This is what the rand_codewords matrix looks like. It has also 4 rows and 8 columns. The next step of this is to copy and paste this rand_codewords from your assignment. So you can just copy and paste it, and to make comments onto how it actually works. So you can see here that the Perm_8 matrix is the indices for the zeros and ones array. So that means that if Perm_8, if the value of the first element, for example, is this 6, that will be put into the zeros and ones array with the value of 6 will replace this Perm_8. So if I go up here and I look at the zeros and ones, I go over 6, I'll go 1, 2, 3, 4, 5, 6 for the 6th element. That 1 will then become the value located at the same place where the Perm_8 index is, which is a 1. It will go through systematically and therefore replace each of the right values in this rand_codewords. So here, the 4 becomes now the index for the 0 and 1, so it goes 1, 2, 3, 4. It's a value of 0, so the 0 goes into that element. The 3 then becomes the next index into this zeros and ones, and again it's a 0, so I expect to see a 0 here. I would suggest as an exercise to go through and verify each of these numbers. So again, put comments in your file to make this explanation in your own words. The next thing we're going to do is use what is called the size function. You can look at the syntax of the size function by doing Shift F1 and typing in size, and it will bring up the syntax for the size. The most common way that size is used is that size will return both how many rows you have and how many columns you have. So what you usually do is you can place these into 2 element values. Mn is equal to size of x. So we know that the zeros and ones has 1 row and 8 columns. So if I did m, n here, is equal to the size of zeros and ones, I expect it to give me the m value to be how many rows. In this case I have one row, and n would become the value of how many elements or how many columns I have, which is 8. So m should become a 1 and n should become an 8. And therefore you see that. If you put these in for a matrix instead of a vector, you'll see the same thing. What we want to use size function for is to create a one-line statement to set variables called number of code words and length of code words to the number of rows, this rand underscore code words matrix. So we want, again, the number of code words to equal how many rows, and the length of code words to equal across for how many columns. So pause this video, use the size function to be able to do that in a one-line statement. Pause the video now. So now that we've created this rand underscore code words array, we can use it to actually create a message. So the terminology here is, one is called a code word, and the code word is the actual message itself. So that is what you usually want to transmit. So what we're going to do is look at a very small data line, and we're going to have it be just 2 bits long. 2 bits meaning either 0, 0 or 0, 1 or 1, 0 or 1, 1. So you can arbitrarily choose any one of those. I'm going to just do 0, 1. And what this translates into is the value of 1. So binary counting goes from 0, this would be 1, 2 would be 1, 0, and 3 would be 1, 1. So just arbitrarily pick any binary data that is a 2-bit sequence, and it can be a 1 or a 0 in any of those places. So how this usually works is you have your data message, which would be your code word, in this case the 0 and 1. You combine a whole bunch of them into a data stream, and this data stream would be very, very long. It usually has extra tagged on information, but we're not going to do that for ours. We're just going to look at a simple 2-bit code word that we want to now translate into an 8-bit code word for data transmission. So we're going to use what is called a code book to do that. So what we want to do is use the 0, 1 binary data, and I want to use that to look at this rand underscore code words and interpret this 8-bit sequence is my code word 0, 0. The next row would be my 8-bit sequence for the binary data code word being 1. If I had the binary data as 2, I would use this row, and if I had the binary data as 3, I would use this row. So in order to do that, I first need to translate the binary data into an actual number from 0 to 3. So to do that, what you always do is you take the first number, you multiply it by 2, and you add the second number, which would be in this case a 1. If it's a 0, then you would add a 0. So to do this, what I want to do is take the binary data and multiply it by a 2 for the first element and a 1 by the second element. So therefore I get a 1, which is what I expect. If I change my binary data, I'm doing this so that it can become robust, meaning that I can put any value of binary data in here and it will still convert it correctly. So this should be a 0. Now I can change my binary data to a 2, which is 1, 0. And I can multiply it and again get 2. And then changing binary data to a 1, 1 should give me a 3. And it does. So I'm checking that to make sure that that's what I do first. So now that I have that, I want to be able to use that as the index to determine the right row. So I want to use that to determine the right row on this rand underscore code words. So I want to use that binary data. This first one is actually the value of 0. But if I used 0 to look up the row of rand underscore code words, I'm going to get an error because Matlab always starts its indexes at 1. So I need to also make sure that I add a 1 to this binary data. So now that I have that, that will be the way I can look up the row in that rand underscore code words. So now what I want to do is use the binary data multiplied by the 2 and the 1. I need to make sure I add 1 to get the right row. And then I want to get everything on the whole rows, which means a colon. So whenever you use a colon, then you are defining that as everything and it's in the columns place, so everything in all of the columns. If I put this is, remember, this is my M, which is my rows, is on the first part of this, comma, and then my columns. So if I put a colon here where all the rows are, it would get all of the rows, and then I could define whatever I wanted on this other side. So here, again, the binary data was 0, 1, so it should grab this row here. And you can see that it did. It got 0, 1, 1, 0, 0, 0, 1, 1. So now if I wanted to take everything in this first column, I would say it as colon to get everything in the first column, and then 1, and it would get everything in this first column. For sake of practice, we're going to extract from this rand underscore code words the second row from the third column through the sixth column, and the third row from the third column through the sixth column. So we want to create the center code, which will have those 2 rows from the third element to the sixth. Again, it's called center underscore code is equal to, and then create the rand underscore code words and put the indices correctly so that you can extract off the second row and the third row from the third column through the sixth column. Pause this video now and try and do this on your own. Pause, please. The next thing that you want to do is create this rand underscore matrix, and this is going to be an 8 by 8 matrix. And what you want this matrix to be is to use the rand_n function. Again, if you've forgotten about the rand_n function, you can use the shift F1 and rand_n. So rand_n will create an n by n matrix, and in this case we want an 8 by 8 matrix, so use rand_n 8, and that will be all you'll need to do to create this rand underscore matrix. The next thing that you want to do is use a logical operator called abs. Again, you can do shift F1 to get the syntax for the abs. This is the absolute value. If you put in an absolute value of x, and x is an array or matrix, it will just take the absolute value of all the elements within that. So if I do abs rand underscore matrix, it should make all of those positive, and you see, yes, it does. So what you want to do is use abs is greater than 0.5. So take each of these elements in here, compare them to 0.5. If I have a value that it is true, a logical value of true, then it will return a 1. If it ends up being false, it will be a 0. And the next thing I want to do is create this new code words matrix. This new code words will have a value of 1 everywhere the rand matrix has a value that is greater than 0.5, and a 0 everywhere else that it does not. And I'm going to type this into the script. After doing that, I want to use the flip LR function. Again, Shift F1. All this does is it flips the columns in the left-right direction around a vertical axis. So call this new codewords 2. And new codewords 2, you can see now that my right side has become my left column. The next one over becomes this next one. This one becomes the third, and so on till I get to the very end, and my left becomes now my far right. So pause this and do that in the script for both the new underscore code words, and then use flip LR to do the new code words 2. The next thing that is wanted is to create this single underscore code word, and what it is the diag function of new code words 2. So it's the 0, 1, 1, 0, 0, 0, 0, 1. And you can see it's there. So type Shift F1, type in diag, and you can see the syntax for the diag. Note that the diag applies to a matrix. It will extract the main diagonal, whereas if you apply the diag to a vector, which here this would be a vector V, it will create a square matrix with the elements of V down the diagonal. So this would actually create this matrix with everything being 0 except for the main diagonal being the value of the vector. So totally different than what we want, so make sure you pick the right one, which was where we want to take from the matrix itself and extract the diagonal part out of it. So this is what the syntax would be, just V, where V is actually a matrix and it will pull on the main diagonal. So X is usually a matrix, V is usually a vector. So again, here you can see it puts V on the main diagonal, and here if it's a matrix it returns the main diagonal of X. The last thing that is needed for this assignment is to create this inverted code words, and what this inverted code words uses the new code words with the bits inverted from a 0 and a 1. So the last thing to be done is this inverted code words. So what this is it uses the new code words. It uses the new code words, and it takes everywhere that there's a 1, it returns a 0, and everywhere a 0, it returns a 1. So use the abs function and subtraction, and in a one-line statement try to use this new code words and get from a 1 Everywhere there's a 1, you want to change it to a 0. Everywhere there's a 0, you want to change it to a 1. Pause this video and do that right now. Finish typing in the error code, save it.
So now that everything is complete, I want to go up and clear the command window and the other two windows. This is an overview of the error code. Once it is run, you can go back and check to make sure you have it all completed. The first thing you should have is the zeros and ones, 4 zeros, 4 ones. The next is this Perm_8 matrix. It's a 4 by 8 matrix. Each row should contain the numbers 1 through 8 in random order. The next is this rand_code words, and you should be able to check to make sure it is correct. At each of the same locations as that of the Perm_8, you should use the value in the Perm_8 to look up the value of the 0 or 1 in the zeros and ones array. As you can see here, it does look correct. Next, you should be able to have the number of code words, which should be the number of rows, 4. The length of code words should be 8. And those are both correct. Next, you should have the binary data. In this case, it's a 0, 1. And the transmit word should correspond to the 0, 1, which is 1, the same row. And in this case, it is correct. To check the center code, you might want to retype at the end center_code along with the rand_code words to check to make sure that it is extracting the correct location of that. So again, it was the rand_code words and not the rand_matrix. So checking this, I do see that this is extracting the second and third rows with the 3rd through 6th columns. And it is correct. Now we want to have the creation of the rand_matrix. It should be an 8 by 8 array, or matrix, 8 by 8 matrix. And it is, and it's varied numbers. Now new _code words should be the absolute values in the rand_matrix. And if the absolute value is greater than 0.5, it should be a 1. Otherwise, it should be a 0. So you can check, and it does look correct. The new _code words 2 is the flipped columns. So the column on the left should be on the right, and the right should be on the left. The single _code word is the diagonal, so you can check that to make sure that the diagonal is correct. And the inverted _code words should be the inversion of the new code words too. So if you need to type out that one to compare them again, you can type it back out to have inverted _code words. And be able to compare that with the new code words too. And the ones should go to a 0, and a 0 should go to the ones. And that does look correct too. So diary off, and that's the completion.